193958086. 193958086. Mongraby ETAL. 3 of 15. The body acts in the 193 Mongraby ET 3 of 15. Our brains, these evaluative abilities rely. It is important to note that the self-awareness abilities, similarly, inner speech has been high. The focus chosen here on self-awareness also prevents a full exploration of other, related, concepts.
Concepts, such as self-reference, self-reflection or rumination, Trapnell and Campbell. Although these may be particularly relevant from a clinical perspective, with excessive self-reference and rumination being the hallmarks of depression, Hamilton et al., and self-reflection potentially being linked to benign interventions, such as mindfulness, Morin, again they may represent higher-order results of more basic self-awareness processes. 2.2 Neurocognitive mechanisms of self-awareness. Crucial notion in relation to self-awareness is that it can be explored at different levels of cognitive complexity, from neuronal electrical activity to self-reported responses. According to this view, self-awareness is not a binary, all or none. 193958086, 2024, 2. Downloaded from https://wiley.wiley.com/doy/10.1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions, https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for rules of use, OA articles are governed by the applicable Creative Commons license. 4 of 15. Mongraby et al. Ability, being best conceptualized as a graded phenomenon. This suggests that self-awareness has deep biological roots, being ingrained in our basic cognitive activity, but also that, during the course of evolution, some of these mechanisms grew increasingly more elaborate. This may be particularly relevant to understand evidence for self-awareness across different species. Even the simplest organisms are capable of self-monitoring for regulatory purposes, but more complex nervous systems potentially allow higher-order, recursive, self-awareness abilities, Lage et al. This is in line with the notion, indicated above, that most self-awareness abilities have their root in implicit self-monitoring processes. While this is more obvious in the case of bodily self-awareness, for example with implicit homeostatic reflexes coordinating basic interoceptive control, quad et al., even higher-order processes can also be considered under a similar framework. For instance, metacognition may rely, at its core, on basic monitoring at the electrophysiological level, for example with event-related potentials linked to the detection and reactivity to errors, Dehenny et al., Gehring et al. The support of self-awareness on lower-level implicit processes may be an important feature to understand this phenomenon from evolutionary and cognitive perspectives. The point at which these self-monitoring abilities lead to subjective awareness remains discussed. One perspective to understand self-awareness would be to consider it as an example of an emergent property. According to this view, interactions at a lower level lead to new properties that are greater than the sum of their parts, and to which a specific identity must be recognized. Artheim and De Domenico, McClelland et al. Within this perspective, implicit sources of information would interact and be integrated into explicit, aware, self-models. The notion of emergence not only prevents rebeing self-awareness, indicating it is a process, rather than a thing in our brains, but also avoids the idea of an infinite regress in relation to selfhood. If more complex levels are but the result of the interaction of lower, less complex levels, the capacities at each level are neither replicated above or below. With decreasing levels of cognitive complexity, subjective experience is lost at some point of the reduction. Dennett. Emergence has been suggested early on as a mechanism for consciousness. Example Sperry. It is intrinsically linked to the established concept of varying levels of cognitive complexity within and across nervous systems, which is supported both by neuroanatomy and evolutionary theory, Lage et al., and also the idea that bottom-up information is organized in increasingly complex ensembles. In this sense, it may fit well with an important framework to understand cognition, and particularly self-awareness, namely predictive coding, PC. PC departs from the notion of the brain as an inference machine, which has its roots in the field of perception studies, including the work of Helmholtz, von Helmholtz, Westheimer, and Gregory. Faced with pressures for survival in an uncertain environment, the brain creates models trying to predict the causes of afferent information. One of the main cognitive tasks within this perspective is to minimize the mismatch between top-down descending predictions and the incoming bottom-up sensory information. Mismatches, or prediction errors, can be minimized either by adjusting prediction, for instance changing beliefs and correcting prior information, or the incoming external information, for example through action on the world, Hawaii. There has been growing evidence for the general ideas of this framework, both from empirical studies, example Dijkstra et al., Koch et al., and computational models, example Lauter et al., Rao and Ballard, with the suggestion that PC emerges from the need of energy efficiency within the physical constraints of the brain, Ali et al. This framework has been used to explain self-awareness processes, and may be particularly relevant to better understand their interactions. In the context of interoception, it has been suggested that afferent information from visceral sources are compared to higher-order predictions about physiological states, Qua et al. Prediction errors would lead to the adjustment of priors and beliefs about interoception, as well as efferent autonomic regulation. Considering agency, comparisons between predicted movements and their consequences with an efferent's copy of the movement and incoming feedback from the body would be linked to the feeling of cognitive control of actions, connate and blank. Similar models can be inferred for other self-awareness abilities, with top-down predictions and ascending sensory information being compared, and adjustments to self-models or engagement with the world being made when mismatches are detected. In the case of declarative, higher-order processes, a similar dynamic may occur between meta, second-order, representations about the self and first-order self-related information. Understanding self-awareness through this general framework may also be particularly helpful to explore interactions between its processes. For example, it has been suggested that interoceptive predictions may impact on explicit forms of agentic action control, with higher interoceptive awareness being potentially linked to increased action regulation for conscious processes, Marshall et al. Interoceptive sensations may also be at the core of emotional experiences, with the suggestion that categorization of physiological information leads to subjective experiences of emotions as discrete states, Feldman-Barrett et al. According to this view, top-down predictions would organize incoming 1939508 2024 2. Downloaded from https://wiley.wiley.com/doy/10.1002/wcs.1670 Wiley Online Library on 24/03/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. Mockery et al. 5 of 15. Figure 1 Integrated Self-Awareness Model, ISAM, a schematic view of the interaction between self-awareness processes. Incoming bottom-up information, represented by thin arrows, is integrated into more complex cognitive levels and meet with top-down expectations and priors, thick arrows, leading to expression of different processes of self-awareness. Mismatches between those two sources of information result in adjustments in either of them or altered self-awareness. Bodily self-awareness emerges from the interaction of interoception, body ownership, and agency, potentially with a nested hierarchy, in which interoceptive sensory signals also feed into the feeling of owning a body and agency. Higher-order processes such as emotional regulation, metacognition, and autobiographical memory are also influenced by implicit bottom-up signals, but are expressed as explicit narrative self-representations, not necessarily with a hierarchical relationship between them. Bodily self-awareness and self-representations interact at the level of specific processes and higher integrated levels, leading to the emergence of an integrated sense of self-awareness. Visceral information into emotional concepts. Another example would be bottom-up electrophysiological error monitoring, in interaction with beliefs about performance, impacting on sense of agency and action competence. There are numerous potential relationships between processes and levels of self-awareness, leading to an integrated feeling of selfhood and self-awareness. Figure 1 presents a schematic view of some of these potential relations. To summarize, the interaction between incoming sensory data from multiple modalities and top-down expectations/priors leads to the emergence of self-awareness. This property is, thus, the result of integration of information across sensory modalities, constrained by expectations and beliefs that exist as a consequence of recurrent experiences of the organism in its environment. The degree to which certain sources of information may be more relevant, example interoceptive data, remains discussed, but it is possible that bodily experiences are at the core of any self-model, in a nested hierarchy approach, Feinberg. Understanding self-awareness from this perspective highlights both its multiplicity and dynamic nature. The focus here is on integration of information across processes and cognitive complexity levels, within a neurobiological approach, as opposed to previous attempts that have emphasized speech and narrative features of self-awareness. Morin. Alterations of self-awareness in clinical conditions. Here a brief overview of alterations in self-awareness across clinical conditions is presented. Far from being an exhaustive list, the conditions highlighted here are illustrative of the type of disruptions that can occur to self-awareness processes and also of the centrality of these alterations in the characterization of these disorders. Table 1 summarizes information about different self-awareness processes and potential conditions in which they are affected. 3.1 Interoception. It is increasingly understood that abnormalities in interoception occur in several neuropsychiatric disorders, particularly conditions characterized by emotional disturbance, Nord and Garfinkel. In mood and anxiety disorders there. 1939508 2024, 2. Downloaded from https://wires.online library.wiley.com/doi/1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions, https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. 6 of 15. Mockery et al. Table 1 definitions about different self-awareness processes and clinical conditions in which they are potentially altered. Self-awareness processes. Definition. Clinical conditions/symptoms. Interoception. Proprioception and body ownership, agency. Metacognition, emotional regulation, autobiographical, sense of the fit, mapping is evidence of increased sensitivity and attention to interoceptive stimuli, that may also occur with reduced interoceptive accuracy, bonus et al. The increased attention to perceived threat seen in anxiety disorders may be associated with alterations in the interpretation or attribution of interoceptive signals, that further establishes anxious beliefs, bonus et al. This may be seen in the catastrophic interpretation of cardiovascular and other interoceptive signals as evidence of a heart attack and panic disorder, and the efficacy of cognitive and pharmacological treatments that aim to correct this misinterpretation, Nord and Garfinkel. Similarly, in depression, a negative view of the self may lead to, and be reinforced by, alterations in beliefs that determine the interpretation of interoceptive signals over the long term, bonus et al., Paulus and Stein. Impairment in interoceptive accuracy and awareness is also seen in functional neurological disorders, FND. In one study, people with functional seizures demonstrated lower interoceptive accuracy and greater subjective sensitivity to internal sensations than controls. The discrepancy between these measures, referred to as the interoceptive trait prediction error, was a strong predictor of dissociative symptoms, Koraki et al., Nord and Garfinkel. People with schizophrenia also demonstrate evidence of reduced interoceptive accuracy, Monti et al. For example, in a study of 23 people with schizophrenia, interoceptive accuracy measured using a heartbeat perception task was significantly lower than controls, Artazi et al., and a recent transdiagnostic study also found evidence for pervasive interoceptive deficits in schizophrenia, Critchley et al. Impairments in interoception are associated with abnormalities in a network of brain regions including the insular cortex, bonus et al. A recent meta-analysis of neuroimaging studies including a range of interoceptive tasks and neuropsychiatric conditions found evidence of a common alteration in dorsal midinsula activation, which may suggest a common role of interoceptive dysfunction across several mental health disorders, Nord et al. 3.2 Proprioception and body ownership. Awareness of body ownership and the relative position of one's own body parts in space, proprioception, have been assessed using a number of experimental approaches, including the rubber hand illusion, RE. In this paradigm, simultaneous touching of a participant's hand with a mannequin's hand may produce the illusion of body ownership of the fake hand, Rossetti et al. Studies using the RE in people with schizophrenia have demonstrated abnormalities in the sense of body ownership, which correlate with the severity of hallucinations and delusions, passivity symptoms, and anhedonia, Monti et al., Pellet et al., Thapkar et al. The impairment of body ownership in schizophrenia may relate to deficits in multisensory integration or body templates, Rossetti et al. Traumatic experiences have also been associated with altered awareness of body ownership, Ravolino et al., and can occur in post-traumatic stress disorder, PTSD, and depersonalization disorders. In depersonalization, part of the body, example a hand, can be experienced as non-self, or there may be complete loss of body ownership where the 1939508 2024, 2, downloaded from https://wires.onlinelibrary.wiley.com/doy/1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions, https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. Maghrabi et al. 7 of 15. Whole body is felt as non-self, Sierra and David. Depersonalization phenomena can occur in the context of neuropsychiatric conditions such as major depression or PTSD, or as a primary disorder, Medford et al. Depersonalization disorder, DPD, is characterized by a reduced sense of self, alteration in emotional experience and change in subjective first-person experience. A recent fMRI study in people with DPD demonstrated alterations in activation of the insula, also associated with interoception, highlighting the importance of this region in processes relating to bodily awareness, Medford et al. 3.3 Agency. Agency, a sense of generating one's own actions, is notably affected in schizophrenia. Here sufferers often report the experience of their thoughts and/or actions being controlled by an external agent, symptoms known as thought interference and passivity phenomenon respectively, Walker et al. In healthy individuals, the sense of being the author of one's own actions has been found to be influenced by both conscious, explicit, and unconscious, implicit, roots, arts et al. To test the functioning of these two roots of influence, explicit and implicit, on agency in individuals with schizophrenia, Rennes et al. Designed an experiment where 23 people with schizophrenia were matched against 23 healthy controls in controlling the movements of a square on a computer screen. They found that, although both groups experienced agency when consciously determining the final resting place of the square, the schizophrenia group were significantly less likely to experience agency when the final resting place was unconsciously primed by 17 milliseconds subliminal displays, Rennes et al. These findings have been replicated by other researchers, Pricken et al., and this impaired sense of agency has also been shown to represent from very early and enthylness, Kozakova et al. Conversely, anosognossic hemiplegic patients with damage to the right hemisphere experience a paradoxically increased sense of agency for movements performed by both plegic and healthy limbs, Cauchini et al. Increased perception of agency may also be behind pathological guilt, with excessive attribution of consequences to one's actions, Petrolini. 3.4 Metacognition. Metacognition, or thinking about thinking, is an area of self-awareness that has been shown to be particularly effective in psychotic illnesses, Lysaker et al. A useful framework and tool for assessment of metacognition is the Metacognition Assessment Scale, MAS, which divides metacognition into three different domains: understanding one's own mind, understanding others' minds, and mastery, which concerns the strategies one employs in the service of regulating one's mental states, Semerari et al. In terms of understanding one's own mind, individuals with schizophrenia demonstrate deficits in self-attributing their own actions, Frank et al., which relate to symptoms such as passivity phenomenon. They also demonstrate inappropriate conviction in their beliefs, Martin et al., which relates to the delusions and the lack of insight that are characteristic of psychotic disorders. Additionally, individuals with schizophrenia exhibit impairments in understanding others' minds, being less able to accurately infer the affective states of other people when compared with healthy controls, Lee et al. This is likely to contribute to the poor social functioning that is commonly associated with this illness, Lysaker et al., which in turn be compounded with the impoverished social schema associated with deficits in the mastery domain of metacognition Xenon schizophrenia, Lysaker et al. Mastery was also found to be significantly impaired individuals with personality disorders, Carcioni et al., while metacognition in general has also been shown to be adversely affected in other psychiatric disorders such as PTSD, Bennett and Wells, and obsessive-compulsive disorder, OCD, and panic disorder, Kuki et al., where beliefs about beliefs are especially important. For instance, in OCD, metacognitive deficits, such as low confidence in memory, may be linked to checking behaviors, either as a cause, Exner et al., or a consequence, Radomski et al. In addition, beliefs about the controllability of thoughts are central to the condition, Purdon and Clark. 3.5 Emotional regulation. Significant impairment of emotional regulation is a cardinal feature of borderline personality disorder and one which is associated with considerable suffering, Bohas et al. In addition to its deleterious impact on sustaining 1939508 2024, 2, downloaded from https://wires.online library.wiley.com/doi/1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions, https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. 8 of 15. Mahrabi et al. Relationships, Miano et al. Increased impairment in this domain is associated with an increased likelihood of suicide attempts in this population, Merkovic et al. A cross-sectional study demonstrated that it is also a feature of this condition that shows little variation over time, with people aged 40 to 59 years still being similarly impaired to those aged 18 to 25 years, Martino et al. The impairment of emotional regulation in borderline personality disorder has been shown to be compounded by comorbid bipolar affective disorder, Bayes et al. Emotional regulation is also found to be impaired in individuals with a solitary diagnosis of bipolar affective disorder, albeit to a lesser degree than in those with a single diagnosis of borderline personality disorder, Bayes et al. Other psychiatric disorders in which emotional regulation has also been shown to be adversely affected include autism spectrum disorder, ASD, Joshi et al., substance misuse disorder, Carolin et al., and attention deficit hyperactivity disorder, LRDETAL. Different disorders may affect different mechanisms of emotional regulation. For example, it has been shown that in social anxiety there is an over-reliance in expressive suppression of emotions, while in major depressive disorder cognitive reappraisal is underutilized. Dreiman and Heimberg. 3.6 Autobiographical memory. Central component of self-awareness is autobiographical memory. Deficits in autobiographical memory are seen in a range of neuropsychiatric conditions and are a characteristic feature of most forms of dementia. In Alzheimer's disease, AD, deficits in episodic and semantic memory contribute to impaired autobiographical self-awareness, Maghrabi et al. Deficits in omnoetic consciousness, the subjective conscious experience that accompanies episodic memory retrieval and involves mental time travel back to the event. Autobiographical knowledge and a sense of continuity of the self occurs at the mild, moderate stages of AD, Huntley et al. People with AD may also be impaired in updating and integrating autobiographical information into their narrative sense of self, leading to a lack of self-awareness of current deficits, Lenzoni et al. Other common neuropsychiatric conditions also demonstrate alterations in autobiographical memory. Autobiographical dysfunction may be both a cause and consequence of depression, Tilarowska et al., with autobiographical memory recall identified as more generalized and less specific in recurrent depressive disorders, Hamlet et al., Hermans et al. People with depression are less able to access specific autobiographical memories in response to positive and neutral stimuli than controls, Young et al., or recall and reconstruct details of events, particularly those that were positive and may not easily integrate with a negative sense of self, Lemebne et al. Similarly, depressed bipolar patients report memories with fewer perceptual and time integration details than those in euthymia or mania, De Silva et al. Overgeneral recall of autobiographical memory also occurs in patients with schizophrenia, with less retrieval of specific memories, which is associated with people with schizophrenia experiencing abnormalities in their concept of self, MacLeod et al., Zhang et al. Alternative frameworks and future research directions. The evidence reviewed here indicates both the pervasiveness and diversity of self-awareness alterations in clinical conditions. The pattern of changes, within and across clinical groups, may help in developing cognitive frameworks to understand self-awareness. Here a PC approach may be particularly helpful to make sense of the data. An initial perspective is to consider that, in some conditions, difficulties may arise in how higher-order processes constrain incoming bottom-up information. For instance, in depression and anxiety, changes in beliefs may affect allocation of attention and the interpretation of interoceptive signals. This may happen even across self-awareness processes. For instance, it is possible that emotional regulation beliefs impact directly on interoceptive processing, Critchley and Garfinkel. This model, with alterations in higher-order constructs leading to changes in lower-level processes, may be helpful in understanding conditions such as OCD, in which beliefs and thoughts about thoughts are central, Myers and Wells. It is possible, however, that the priors themselves are either reinforced or formed on the basis of distorted information. This would lead to two different perspectives. 1. Concomitant changes in low and higher order processes, with an altered interpretation of signals reinforcing beliefs and beliefs constraining signals, in a cycle. 2. A primarily bottom-up origin for difficulties, with beliefs being formed from disrupted incoming information. Still in the example of 1939508 2024, 2, downloaded from https://wires.onlinelibrary.wiley.com/doy/1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions, https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. MACRB ETAL 9 of 15. OCD. It is possible that limbic hyperactivation and disrupted emotional processing lead to the altered thinking patterns of the condition. Simon ETAL, Thorson ETAL. In conditions such as schizophrenia, problems seem to appear across self-awareness processes, for instance with increased interoceptive sensitivity, poor bodily integration and decreased agency, but also metacognitive distortions. In this case, it is harder to suggest a straightforward chain of causality. These findings may suggest either a concomitant origin or a spurious correlation. In the latter, other changes, central to the condition, would lead to the profile of self-awareness alterations, which can either be considered an epiphenomenon or a reinforcing factor in the subjective experience of patients. The expansion of a transdiagnostic approach to study self-awareness may deliver results with relevant clinical and theoretical implications. For instance, exploring how different self-awareness processes are affected across disorders may reveal shared diagnostic characteristics, going beyond a categorical approach. This is consistent with recent efforts to describe psychopathology in terms of dimensional features, Cuthbert, and may indicate relevant targets for intervention, both for pharmacological and psychosocial treatments. Although there is already some existing evidence, such as the studies reviewed in the previous section, further data collection may assist in determining mechanisms behind self-awareness in health and illness. Conversely, exploring different self-awareness processes within single clinical conditions may not only provide important resources for interventions, but also shed light into the cognitive mechanisms of self-awareness. For example, investigating how bottom-up and top-down processes from different self-awareness subdomains interact may indicate if there is a hierarchical relationship between these subdomains, with some capacities being nested in others. Feinberg. Exploring a variety of self-awareness processes within the same condition may also help clarify the interaction between self-awareness levels and the mechanisms leading to the emergence of subjective experience. For this to happen, methodological advances in how to quantify self-awareness are needed. Different approaches have been used depending on the specific self-awareness process, including questionnaires, example Maya, Medling ETAL, behavioral tests, example agency, Imaizamai and Tano, and physiological measures, example measurement of event-related potentials for error monitoring, Lenzoni ETAL, resting state magnetic resonance imaging, HAM ETAL, but comparatively fewer studies have integrated methods across these measurement levels. For example, the development of self-awareness test batteries, including questionnaires and behavioral measures, which can be coupled with physiological data, may elucidate the relationship between self-awareness levels and processes. Privileging ecological validity is another important focus. Focus for the development of new measurements, for instance with the use of virtual reality, which can provide immersive environments maintaining experimental control. Additionally, the development of new methods that can tap into the level of self-awareness of people with disorders of consciousness, example persistent vegetative state, coma, is particularly relevant from an ethical point of view, for instance impacting on end-of-life decision-making. Elucidating the neurochemical basis of self-awareness may have direct implications, not only for our understanding of this phenomenon, but also for diagnosis and treatment of neuropsychiatric conditions. An approach would be to identify which neurotransmitters are implicated in alterations of self-awareness. For example, the role of dopamine in agency has been suggested, with higher accessibility of dopamine potentially increasing sense of agency, Render and Janssen. Such findings would indicate targets for intervention, new potential therapies, and highlight clinical groups who are more vulnerable to these changes. Another avenue of research would be to explore substances with traditional use that more recently have been incorporated into mainstream treatments. For example, psilocybin has been known to lead to changes in the sense of self, with users typically reporting ego dissolution, a reduction of self-reference, and a disintegration in the boundaries between the self and the world. In both negative and positive experiences with psilocybin, Buman et al. Considering the boom in research on psychedelics, investigating self-awareness may help bringing some of these compounds into clinical practice, also providing resources for a cognitive neuroscience of self-awareness. Finally, exploring self-awareness across species may be crucial to understand the origins of this phenomenon and its evolutionary pathways. A comparative approach may indicate the extent to which levels of self-awareness are present in other species, as well as the particularities of certain processes in specific clades, Lage et al. Expanding our knowledge about the level of self-awareness of other species may have an important impact in our relationship with them. This evolutionary perspective may also shed light into another frontier of human knowledge, namely the capacity of devices to become self-aware. Various attempts have been made to explore this issue, Chella et al., McCarthy, Scoits, for example, investigating the extent to which inner speech may be linked to self-awareness in robots, Chella et al. This could help revealing if inner speech is sufficient for the development of self-awareness, or, rather, which type of self-awareness may emerge from such an 1939508 2024, 2. Downloaded from https://wiley.wiley.com/doy/10.1002/wcs.1670, Wiley Online Library on 24/03/2025. See the terms and conditions. https://onlinelibrary.wiley.com/terms-and-conditions. On Wiley Online Library for Rules of Use, OA articles are governed by the applicable Creative Commons license. 10 of 15. Mograbi et al. Attempt. While an evolutionary approach may indicate whether this construct is necessary or not, by exploring self-awareness in devices and increasing our understanding of the biological conditions in which self-awareness emerges, we will be more equipped to develop models and simulations of the phenomenon, also increasing our knowledge about the relevance of the material support grounding self-awareness, as well as its potential to be instantiated elsewhere. Conclusions. The search for self-awareness has been a journey for our species, with answers to this question being traditionally provided by religion and philosophy. A cognitive neuroscience of self-awareness has only been emerging in the past few decades, but growing evidence has been shedding light into the phenomenon, not least in the case of neuropsychiatric conditions, as reviewed here. It is expected that the expansion of this field will have implications for theoretical, clinical, and ethical perspectives. One important limitation of the current review refers to the lack of evidence from across conditions, with few studies directly comparing different disorders. Although such studies are indeed scarce, we hope that the current work will motivate researchers to pursue this further, not least because this transdiagnostic approach may also be relevant clinically. Additionally, some may argue against the attempt to bring processes as diverse as interoception and metacognition under the umbrella of self-awareness. Indeed, part of the scientific endeavor is grounded in breaking up reality into smaller components, in order to better understand its mechanisms, then reassembling its pieces. The approach indicated here does not replace the need for the examination of individual self-awareness processes, but suggests that exploring these together may reveal shared mechanisms and interactions that could be harder to identify in isolation. Our cognitive faculties have evolved with the sole purpose of keeping us alive, helping us to navigate the environment and identify internal demands and their level of satisfaction. Within this perspective, cognition is self-serving by definition. By exploring the mechanisms of self-awareness, a finer understanding of brain function and cognitive processing may be achieved, helping us to answer the perennial question of who we are, both from a mechanistic and a subjective perspective. Author contributions Daniel Mockery, conceptualization, equal, methodology, equal, writing original draft, lead, writing review and editing, lead. Simon Hall, conceptual.
Imprint logo. Journal. Review article. Contents 1. Naturalization.
Naturalization of self-awareness, its biological function, and how it may be investigated. 765-2. The Paralympic Network associated with self-awareness. 767-3. From association to causality. 7694. Pathophysiology, the importance of oxygen homeostasis. 775. Consequences for treatment and prevention. 771. Acknowledgement. 771. References. 771. 1. Naturalization of self-awareness, its biological function, and how it may be investigated. Self-awareness provides the information essential for conscious self-monitoring, metacognition. Metacognition is a tool for consciously controlling behavior and adjusting our experiences of the world. It is essential for learning by conscious experience, not only within ourselves, but, importantly, also between individuals. Barm et al., 2010. Self-awareness is therefore of decisive importance by giving humans an advantage in phylogeny. Favreau et al., 2015. Lagerkrantz and Changeover, 2009. Blue, 2012. Kerner and corresponding author. Email addresses: hanslu1@gmail.com, hclu, changeux@noas.fr, jpchangeover, rosenstn.astrid@gmail.com, a Rosenstand. Rosler, 2012. Self-awareness was until quite recently considered off-limits for the natural sciences. More specifically, neurobiological research has shunned the hard question of how and why consciousness and self-awareness arise from a physical basis, considering it inaccessible with current technology. Following Chalmers D.J. Chalmers, 1996, Cook, 2009, Blue, 2012, Nifsi, 2009. The difficulties encountered in investigating the biology of self-awareness have been discussed by Zahavi and Roepster, 2011. They draw attention to the discrepancies between the effort applied to setting up self-awareness experiments and discussing the experimental results, while disregarding the very notion of the concept of self-awareness. More radically, Drizk stresses that there are explanatory challenges related to consciousness per se and puts forward the theory that we never have experiences of ourselves, but only on the contents of consciousness. Mehta and Mashauer, 2013. 766h.c.loedl/Neuroscience and Biobehavioral Reviews 83, 2017, 765, 773. Image of Fig 1. Fig 1. Cerebral activation patterns vary with shifting contents of consciousness. All conscious states are linked to activity in a medial paralimbic network. A. The four upper rows represent cerebral blood flow patterns measured with 15-OH2O PET during Yoga Nidra meditation on weight of own body part. Upper row, abstract perception of joy. Second row, visual imagery of landscape. Third row, and symbolic representation of self. Lower row, with permission. Liu et al., 1999. B. The right medial parietal cortex, precuneus, prefrontal cortex, and right striatum are activated in all meditative states and in the control state. Liu and Cager, 2005, with permission. H.C. Blue. E.T. Al. Neuroscience and Biobehavioral Reviews 83, 2017, 765 to 773, 767. Image of Fig 2. Fig 2. The Paralympic Network and Narrative Self-Awareness. Retrieval of previous judgment of oneself activates a paralimbic network of medial prefrontal/anterior cingulate, anterior hub, and medial parietal/posterior cingulate cortices, posterior hub, together with thalamus. Changeover and Liu, 2011, with permission. In contrast, Damasio, 2000, Gallagher, 2000, following Wittgenstein and the phenomenologists, claim that we are self-aware whenever we are conscious. Consequently, attempts at separating the notions of self-awareness and familiarity may seem futile, e.g. Koponen, 1999. Accordingly, self-awareness is an indispensable part of our experience of the world, whether it is minimal self-awareness, pre-reflective, with an automatic sense of ownership of the experience, or narrative self-awareness, extended in time by retrieval of personal memories and thereby allowing predictions of the future. Ingvar, 1985. Minimal self-awareness may be investigated using rapidly presented visual stimuli of varying duration, Weisskranz et al., 1995, and by first-person vs. third-person perspective, Vogeli et al., 2004. Narrative, extended, self-awareness may be investigated using retrieval of episodic memory of previous judgments. Both minimal self-awareness and narrative self-awareness may be ranked according to degree of self-reference. Craig et al., 1999. This approach has allowed recent research to surpass earlier limitations and gives us insights into the biological origin and function of self-awareness, and how its impediment in disease may account for major disorders in conscious regulation, with consequences for treatment and prevention. 2. The paralimbic network associated with self-awareness. Shifting cerebral activation patterns occur with changing contents of consciousness during mind wandering, both during yoga nidra meditation and in